In this lesson, we're going to look at what we mean by average rate of change. Now, average rate of change corresponds to the slope of a line. So we could just write it like this. So corresponds to the slope of a line. And you've all had experience with finding the slope of a line. So when we talk about average rate of change, let me go ahead and rewrite it here. So the average rate of change, average rate of change, we're going to denote it as the change in the output, so change in output divided by change in input. Okay? And when we think about output, we think about the y value. When we think about input, we think about the x value. So I'm going to write this as change in y divided by change in x. Okay, change in y divided by change in x. And sometimes you'll see this as well. So when you think about change in y, we think about delta y. So delta means change. So change in y, delta y, and then delta x. And so when you think about the slope, you think about y2 minus y1 over x2 minus x1. So change in y divided by change in x. So the average rate of change corresponds to the idea of slope, and all of these means the same thing. So all of these expressions here mean the same thing. They're equivalent. Okay? And so so what we're going to do though is when we look at this, you're going to be looking at this in terms of functions. For the first part will be listed as functions. So for example, let's suppose, so this will be example number 1. So example number 1. All right, so in example number 1, let's suppose we had this function, f of x equals 3x minus 2. All right, and the question is this: what is the average rate of change in the interval from -2 to 5? In the interval -2 to 5. Now, just to let you know, notice you have brackets here. You could see an open interval instead. So these could easily have been parentheses, but it doesn't matter whether it's brackets or parentheses. You want to know, though, what is the average rate of change in the interval from -2 to 5, okay? All right, so if I'm going to find the average rate of change of this function from -2 to 5, I've got to first of all find those y values as well, right? So here are those endpoints. So basically what you're going to do first of all is use my function f. So what you're going to do first of all is you're going to find f of -2 and you're going to find f of 5. So you have to find what's the y value that corresponds to -2 and what's the y value that corresponds to 5. So that's that numerator, changing y values. Okay? So when x is -2, what's my y value? And when x is 5, what's my y value? Okay, well, that's easy to figure out. So you just go to your function f, and where we see the variable x, is substitute -2. So f of -2 would be 3 times -2 minus 2. So that's -6 minus 2, which is -8, right? So f of -2 is -8. F of 5, you do the same thing. So f of 5 will be 3 times 5 minus 2. So that's 15 minus 2, which is 13. Okay, so now let's go ahead and find the average rate of change. So the average rate of change, average, E-V-E-R-A-G-E, average rate of change, okay, will equal, all right, now see how I have y2 minus y1, and remember the idea of slope, y2 minus y1. If you start with y2, you must start with x2 in the denominator. So these are your x values right here, -2 and 5. So when I do this, if you put 5 first, then you have to put f of 5 first in the numerator. So 5 subtract -2. So watch what happens. 5 subtract -2. So remember x2 minus x1. So x2, x1, x2, x1. All right, so 5 minus a -2. Now, since I started with 5, I've got to put my y value that corresponds to 5 up there. So the y value that corresponds with 5 is f of 5, right? And then minus, and then f of -2. So I can rewrite this part here to look like this function notation. So in other words, I can write this as this now, f of x2 minus f of x1 all over x2 minus x1. All right, so x2 minus x1. So f of x2 must correspond to x2, f of x1 must correspond to x1. So f of x2 is this y2, and f of x1 is this y1. All right. Now, f of 5 we found to be negative 8. So in place of f of 5, put negative 8 minus f of negative 2 we found to be 13. I'm sorry. F of 5, I'm sorry, is 13. Excuse me. F of 5 is 13, so be careful. Don't do what I just did. F of 5 is 13 minus f of negative 2, which is negative 8, divided by 5. Subtract a negative 2 means 5 plus 2, right? Okay, 13 subtract a negative 8 means 13 plus 8. And then 5 plus 2 is 7. 13 plus 8 is going to be, what's that, 21? And 21 divided by 7 is 3. So the average rate of change, the average rate of change is 3. The average rate of change is 3. All right, so that means that for each unit increase in here, in that interval from negative 2 to negative 1, from 1 to 0, from 0 to 1, from 1 to 2, and so on, this function is increasing by 3. Okay? The y value is increasing by 3. I want you to notice something, though. You remember a while ago we said this. We said the average rate of change corresponds to the slope of the line, right? Well, isn't this a line right here? Isn't this a line? This function is a line, right? What is the value of x? The value of x is 3. So remember slope-intercept form? So let me write this right here. Let me do it here. So f of x equals 3x minus 2. And f of x means the same thing as y, right? Y equals 3x minus 2. Well, this line has what slope? This is slope-intercept form. This line has slope 3. So the answer better be 3. But there's the work. Now, the one on your test won't be a line. It'll be a different function. But that's the idea. All right, so that's how you find the average rate of change. So for every change in, for every 1 unit increase in x, my y value is increasing by 3. That's what that means. Okay, so that's number 1. So number 1, you're giving a linear function. So you had to know if this was linear that the slope is 3. So when you do all this work, you better still come out with 3. But let's do one where the function is not linear. So it's not that easy to see what the average rate of change is. So let's look at number 2. All right, here's number 2. What is the average rate of change between 4 and 16? So in other words, when I go from 4 to 5, 5 to 6, 6 to 7, 7 to 8, and so on, what is my y value increasing by each time? That's the question. All right, so to find the average rate of change, when you're given the function, here's what you're going to do. Average rate of change. So remember, the average rate of change corresponds to the slope between between x equals 4 and x equals 16. So the average rate of change is defined to be f of x2 minus f of x1 divided by x2 minus x1. So this will be your x1, this will be your x2. So I know right away my denominator, I'm going to say 16 minus 4, right? And so to find the numerator, I got to find those y values. So remember slope y2 minus y1 divided by x2 minus x1. So I got to find those y values. Well, those y values could be found by finding f of x2 and then f of x1. So x2 here corresponds to 16, so I got to find f of 16. And then once I find f of 16, I'm going to subtract, this is 4, right? I'm going to subtract f of 4. So let's go ahead and do the work for the numerator. So f of 16 is going to equal 2 times 16 minus 3 times the square root of 16. 2 times 16 is 32. And then square root of 16 is 4, right? So that's 3 times 4. So that becomes 32 minus 12, and 32 minus 12 is 20. So far I have 20 for f of 16. I'm going to subtract from 20 whatever f of 4 is. So I got to do the work for that. So f of 4 will equal 2 times 4 minus 3 square root of 4. 2 times 4 is 8. And the square root of 4 is 2, so that's 8 minus 3 times 2. So that's 8 minus 6, which is 2. So I get 20 minus 2 divided by, and then 16 minus 4 is 12. 20 minus 2 is 18, and 18 divided by 12. And let's just go ahead and leave it as a fraction reduced. So 18 divided by 12 is going to be, they're both divisible by, 6? So it'll be 3/2. So that's your average rate of change. So the average rate of change is 3/2. So when I go from 4 to 5, my y value is increasing by 3/2, 1.5, right? If I go from 15 to 16, my y value increases 1.5 by 3/2. Okay, that's what that means. All right, so that's number 2. Your average rate of change is 3/2. Okay, number 3, let's get number 3. So number 3, let's look at this function. All right, this time our function is x squared minus 2x. And the question is, what is the average rate of change between the interval -3 to 5? And I went ahead and put an open here just to remind you that it did not matter whether you put brackets or open, does not matter. Or parentheses, I should say, does not matter. All right, but you want to find the average rate of change from -3 to 5. That's what you want to find. All right, so remember the average rate of change, the same idea as it corresponds to the slope of a line from -3 to 5 for this function. All right, so we're going to, so the average rate of change, remember, is, and it helps if you write it out, so your denominator is going to be x2 minus x1. So if this is your x value, you got to find your y value. So your y value would be f of x2 minus, if this is your x value, your y value would be f of x1. x2 in this case, I'm going to denote it as 5, and x1, I'll denote it as -3. So this becomes in the denominator, 5 subtract the -3. So if x is 5, to find my y value, I'm going to find f of 5. And then subtract, and then if x is -3, I'm going to find my y value, which would be f of -3. Okay? So now let's go ahead and find f of 5. So f of 5 will equal 5 squared minus 2 times 5. So 5 squared minus 2 times 5. Well, 5 squared is 25, and then 2 times 5 is 10. So 25 minus 10 is 15. So I get 15 for f of 5. I'm going to subtract f of -3. So f of -3, same thing. You're going to square -3. So it'll be -3 squared in parentheses minus 2 times -3. Well, -3 squared is 9. A -2 times a -3 is a +6. And then 9 plus 6 is 15. So I got 15 minus 15. Okay? And then the denominator, I have 5 minus a -3, which is 8. So I get 15 minus 15, which is 0, and 0 divided by 8, which is 0. So I get 0 there. So the average rate of change is 0. Okay, so what does that mean, that the average rate of change is 0? All right, well, that means this. So let me kind of show you what the graph looks like. So here's the graph of x squared, this quadratic function, x squared minus 2x. All right, this is a rough sketch of the function y equal x squared minus 2x, or f of x equals x squared minus 2x. You're going to learn how to graph this in another section, but this is what the graph basically looks like. So the question is this. So here is, remember you went from -3 to 5, right? So here is -3, 1, 2, 3 right here. And then here's 5. 1, 2, 3, 4, 5 right here. So from -3 to 5, remember the average rate of change is the slope of the line from x equal -3 to x equal 5. So here's the point that corresponds to x equal -3. Here's the point that corresponds to x equal 5. Notice that this segment here is horizontal. Well, what's the slope of a horizontal line? Well, the slope of a horizontal line is 0. That's what you found. So when I go from -3 to -2, or from -2 to -1, or from 1 to 0, my y value hasn't changed at all. My y value stayed the same. That's what that means. Slope is 0. My y value stayed the same. So the y value stayed the same. It did not change. Okay? So in each of these cases, my y value was 15. Remember right here, y value 15? That's what that means. The y value did not increase at all. The y value stayed the same. That is what average rate of change of 0 means. That from this point to that point, when x, remember you're looking at -3 and 5. So when x is -3, here's the point of the graph. When x equals 5, here's the point of the graph. When I connect those two, that's a horizontal segment. The slope of a horizontal segment is 0. Remember, the slope of a horizontal line is 0. So that means the y value stayed the same. The y value did not change at all. Okay, so that's what that means. But just make sure that you're able to find the average rate of change using this concept. The average rate of change is f of x2 minus f of x1 divided by x2 minus x1. Okay? All right, let's look at another one. Let's look at number 4. All right, so I have this function. Again, it's quadratic. F of x equals negative x squared plus 5. And I want to find the average rate of change between 1 and 5. Okay, so to find the average rate of change, so here's going to be your work, average rate of change. So you're going to say, remember the formula is x2 minus x1. So to find the y value, you're going to say f of x2, right? And then you're going to subtract the y value that corresponds to f of x1. So in this case, this is your x1. This is your I'm sorry. Remember, this is not a point. So this is your x1, and this is your x2, right? So that's your x2. So x1, x2. So remember, that's not a point. That's an interval going from x equal 1 to x equal 5. So x1, x2. All right. So then you're going to say, in the denominator, you're going to say 5 minus 1. The numerator, if x is 5, you're going to find the y value, which is f of 5. And then subtract. If x is 1, you're going to find f of 1. And then let's go ahead and find f of 5. So f of 5 will be negative, in parentheses, 5 squared plus 5. And then negative, remember 5 squared is 25, so that becomes negative 25. Negative 25 plus 5, which is negative 20. So this part's negative 20. So I get negative 20, subtract, and then we do the same thing for f of 1. So f of 1 will equal negative 1 squared plus 5. 1 squared is 1, so that becomes negative 1. Negative 1 plus 5 is 4. And then in the denominator, you have 5 minus 1, which is 4. The numerator, a negative 20 and a negative 24, is a negative 20 and negative 4 is a negative 24 divided by 4, which simplified becomes negative 6. Okay, so negative 6. All right, so we found the average rate of change. So the average rate of change for f of x, which equals negative x squared plus 5, between 1 and 5 is negative 6. That's what we found. Okay, so that means that when x goes from 1 to 2, from 2 to 3, from 3 to 4, from 4 to 5, my y value is decreasing by 6. So you see negative 6, that means my y value is decreasing by 6. That's what that means. Okay, so this means that the y value is decreasing by 6 for every increase of 1 unit in x. So remember, when I went from, increasing by 1 unit, 1 to 2, 2 to 3, 3 to 4, 4 to 5, my y value is decreasing by 6 each time as I go from 1 to 2, 2 to 3, 3 to 4, 4 to 5. Okay, that's what that means. All right, let's look at this one. So this would be number 5. All right, so let's suppose that Susan weighed 135 pounds in the year 2000. And then in 2020, Susan weighed 185 pounds. So you can see that the pound increased, right? That the weight increased. So the question is, what is Susan's average rate of change in weight? All right, so remember that corresponds to slope. So since since the weight increased, do y'all agree that the average rate of change is going to be positive, right? So the average rate of change has to be positive because you're increasing in weight. You're going from 135 to 185. So let's find the average rate of change. So remember the average rate of change is, remember the if this was a function, and you can think of this as a function, you would say f of x2 minus f of x1 divided by x2 minus x1. Okay, so let's think of the denominators being the year. So I'm going from 2000 to 2020. So let's say 2020 minus 2000. And so the y value that corresponds to 2020, the y value that corresponds to 2020 is going to be 2020 would be what, 185? So 185 minus, and the y value that corresponds, or the weight that corresponds to the year 2000, so the weight that corresponds to the year 2000 is 135. So if I subtract those, I'm going to get 185 minus 35. 135 is 50, and then that's how many years altogether? 20 years. And so 50 divided by 20 would be 5 halves, which is what, 2.5? So what does that mean, that 2.5? Well, this is what that means. So that means that Susan, so remember when we talked about the average rate of change here being -6, remember how it went from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and I said each of those increase in units, the y value decreased by 6. So what this means is that from 2000 to 2001, from 2001 to 2002, from 2002 to 2003, how much weight is Susan gaining per year? And that's what this is right here. So Susan is gaining 2.5 pounds per year. That's what that means. So Susan is gaining, or Susan gained, I should say, Susan gained 2.5 pounds per year from the between 2000 and 2020. Okay? And it's positive. It had to be positive because notice her weight increased. So from 2000 to 2020, her weight increased. All right, that was number 5. Now let's look at number 6. All right, so number six here, you're given the graph of this function. And the question is, what is the average rate of change between x equal -1, so here's x equal -1, and x equal 2. So in previous examples, it would have said something like this: find the average rate of change between -1 and 2. Same thing. So x equal -1, x equal 2. All right, so remember the average rate of change is the slope of that line, right? The slope of that line. So let's look at the slope of that line. So if I look at the point, the point that corresponds to x equal -1, so x equal -1, so here's x equal -1. So remember that one of the previous lessons, you took a ruler and you labeled, and you put the point that corresponds to the function, so that's this. So here's where x equal -1, and then here is where the point where x equal 2, right here. Okay, and if I connect those right here, that's that line that we keep referring to. So the slope of that line. So notice that my line is falling, right? So when I find the average rate of change, it needs to be a negative number because my line is falling. So from x equal -1 to x equal 2, I get this line and it's falling, so the slope better be negative. So the average rate of change needs to be negative. All right, so let's find it. So the average rate of change, now remember what we did. We said y2 minus y1 over x2 minus x1, right? So another way of saying that is this. So let's, x2 will be 2 and x1 will be -1. So x2 minus x1. So 2 minus a -1. To find that y value here, I gotta ask myself, what is y when x is 2? Well, when x is 2, I get the point 2, 1. So what is the y value when x is 2? Well, the y value when x is 2 is 1, so I get 1 here. So when x is 2, my y value is 1, right? Minus, and then do the same thing with negative 1. When x is negative 1, what's my y value? Well, the point here is negative 1, 4. So when x is negative 1, what's my y value? My y value is 4. So then I get 1 minus 4, which is a negative 3, and then 2 subtract a negative 1 means 2 plus 1, so that's 3. So I get negative 1. All right, so the average rate of change is negative 1. So the average rate of change from x equal negative 1 to x equal 2 is negative 1. So what does that mean? So that means that when I go from negative 1 to 0, my y value is decreasing by 1. And it makes sense, right? Because look, I went from a y value of 4 to a y value of 3. What's 4 minus 3? 1. When I went from 0 to 1, my y value is decreasing by 1. So I went from 3 to 2. So what's 3 to 2? 1. And then from this point to that point, my y value is decreasing. You see right here it's 2, and then right here it's 1. 2 minus 1 is 1. So that's what that means. So each of those from here to here, my y value decreases by 1. From here to here, my y value decreases by 1. From here to here, my y value decreases by 1. That's what that means. Okay? Let's look at another one with the same graph. So let's look at this interval. Let's find, for this one right here, this will be number 7. Let's find the average rate of change. Find the average rate of change. Find the average rate of change between, and let's say I want to go between 0 and 3. 0 and 3. All right, 0 and 3. Okay, so x is 0, x is 3. All right, so here is where x is 0. You see this right here? So that's this point here, right? So from here, and then this is where x is 3, this point here. So I want to know what's the average rate of change. What's the average rate of change from x equals 0 to x equal 3? That's the question. So what's that average rate of change? So notice the average rate of change will be positive, won't it? Because my line is increasing. So this answer here should be positive. Okay, so let's find it. So that's going to equal the average rate of change between 0 and 3 will equal. So let's talk about the denominator. So the denominator will be 3 minus 0. And let's look at the y value that corresponds to 3. So when x is 3, what's my y value? My y value is 4. Minus, when x is 0, what's my y value? Well, my y value is 1, right? So this is 0, 1. And so 4 minus 1 is 3. 3 minus 0 is 3. 3 divided by 3 is 1. So the average rate of change between 0 and 3 is a positive 1. We knew it had to be positive because that line is increasing. So what does that mean? That means from 0 to 1, and then from 1 to 2, and then from 2 to 3, look at what's happening. From 0 to 1, my y value goes from 1 to what? To 2. Well, that's an increase of how many units? 1. Then it goes from 2 to 3. See that 3? That's 1 unit. And then from 3 to 4, that's another unit. So that's what that 1 means. So from 1 to 2, my y value increases by 1. From 0 to 1, my y value increases by 1. From 1 to 2, increases by 1 also. And then from 2 to 3, by 1 again. Okay? That's what that means. Your y value is increasing by 1. All right, let's look at another one. All right, let's go to number 8. Find the average rate of change between 1 and 3. Between 1 and 3. So remember, the average rate of change, you're going to say 3 minus 1, and then up here, and let me just they call this g, function g. So let's say you're going to find g of 3, and then you can subtract g of 1. So find the y value that corresponds to 3. Find the y value that corresponds to 1. So remember, though, you are going from 1 to 3, right? So from x equal 1, there's the point of the graph, to x equal 3, there's the point of the graph. So you are trying to find the average rate of change from 1 to 3, right here. So notice that this line is positive, so the answer is going to be positive. All right, now, look at the y value. So when I look at this point here, that's that point 1, 0, and this point here is 3, 4. So g of 3, so when x is 3, what's my y value? Well, when x is 3, my y value is 4, right? Minus, and then g of 1, what's the y value when x is 1? Well, my y value is 0. Divided by, and then 3 minus 1 is 2. So I get 4 minus 0 is 4, divided by 2, which is 2. So what does that mean? The average rate of change between 1 and 3 is 2. What that means is this. Listen carefully. From 1 to 2, and then from 2 to 3, so you're going from 1 to 3, right? So for each 1 unit increase in x, my y value increases by 2. So look, from 1 to 2, look at that y value. That y value is 0. So I went from 0 to what? 2. How many units is that from 0 to 2? That's 2 units. And then from 2 to 3, look at what happens. From x equal 2, which was right here, right? X equal 2. Let's see. Let me go back again. From 1 to 2. From 1 to 2. See, that's that line right here, right? Right here. So from 1 to 2, that y value is 2. So I went from 0 to 2. And then from 2 to 4, I went from y equal 2 to y equal 4. That's 2 units. So that's what that means. So when you look at that line right here, that slope is 2. So from 1 to 2, I went from y equals 0 to y equal 2. So that's 2 units. And then from 2 to 3, my y value went from 2 to 4. So that's 2 units as well. That's what I mean. So you're looking at that slope of that line from x equal 1 to x equal 3. Okay? All right, so that's what that means. So the average, so on average, when you go for this function here, from 1 to 4, from 1 to 3, from x equal 1 to x equal 3, the average rate of change, which is the slope of that line here, is 2 units. Now, you're going to learn later on in calculus that also represents the slope of the secant line. So that would be considered a secant line, which, remember, we talked about the difference quotient, right? So that also has relation to the difference quotient. So that's the average rate of change. It is somewhat difficult to understand, but it's really not that bad. It's really not that bad to understand when you can visualize it. All right, let's look at this one. So this one's hard to see, so I'm going to have to kind of indicate what those points are. So for this problem, let's go ahead and find the average rate of change. Find the average rate of change between -2 and 0. So this point here, let me go ahead and write it. So this point here that you see here, that's -2, 4. And this point here, right here, is 0. This is 0, -6. So that point is 0, -6. You can't see it. And this is 2, 4. Okay, so you want to find the average rate of change between in the interval -2, 0. So if I were to look at that line, the slope going from here to here, so let's connect them from here to here. See that line? You see that line's decreasing, right? So the average rate of change better be what kind of number? It needs to be a negative number. All right, so let's see from when x goes from -2 to -1 and from -1 to 0, what are my y values changing by? Okay, that's the question. All right, so remember the average rate of change, you're going to say in the denominator, so that this will be your x1, this will be your x2. Remember, that's not a point, so be careful. That's an interval from -2 to 0. So those are that's your domain you're looking at. All right, so you're going to say 0, subtract the -2. And then to find the y value corresponds to this, let's say this is your function f of x. So you're going to say f of 0 minus f of -2. Okay, so let's find f of 0. So the question is, what's the y value when x is 0? Well, you know what that is. Well, so when When x is 0, what's my y value? My y value is negative 6. Subtract f of negative 2. What's the y value when x is negative 2? Well, when x is negative 2, my y value is 4. And then 0 subtract negative 2 means 0 plus 2, which is 2. The numerator, a negative 6 and a negative 4 is a negative 10 divided by 2, which is a negative 5. So what that means is this. When x goes from negative 2 to negative 1, 1 unit increase, my y value is decreasing by 5 units each time. So when I go from negative 2 to negative 1, my y value went from, see that 4 right here? So it's decreasing from 4 to negative 1, 5 units. Then from negative 1 to 0, it decreased another 5 units. Okay? So 5, 5. That's what that means on average. So the average rate of change. Okay? All right. So that is going to conclude the concept on determining the average rate of change. It is not an easy topic for many students. It's very if the diagram, if there's no picture available, it's kind of hard to understand. But just try and do your best with understanding the average rate of change and how it corresponds to the slope of a line. And I think you'll be okay. All right, so that's going to be the end of this lesson.